Okay, so let's take a look at this one here. So this one is asking us to find the values of I1 and I2. So let's take a look at it here. We know that current is going to leave this source, travel this way, come down through here, and then it's got an option. It can go down either path. So it'll send some that way, it'll send some that way, and then they'll meet up with each other and combine back together. Okay. What we want to know is they're calling this I1, they're calling this I2, what those values are. So in the beginning part of the course, you're going to use V is equal to IR for most of these. But let's take a look at how that's applied. So looking at the circuit, let's see a couple things that we know. We said that to use V is equal to IR, we typically want that one source and one resistor. So if we look at here, we see that these are in parallel. And if we go and combine those down in parallel real quick, we'll see R parallel 1 will be 8 times 8 over 8 plus 8. 4 over 16, which will give us 4. So 4 ohms. And if we were to redraw that, six, and then 4, 10 volts. All right. So now here, we still have I1 coming through. Now, these aren't one resistor yet, so we still need to combine these down. So this is series 1. So if we combine series 1 down, it'll be 6 plus 4, which will give us 10. Okay. So when we do that, we'll end up with 10 volts and then 10 ohms. And then we still have I1 now. It's still leaving. Notice how that I1 hasn't changed. It's still the same wire consistently exiting that battery. So we can say if V is equal to IR, then we can say I is equal to V over R, which in this case is 10 volts over 10 ohms, which will give us 1 amp. Right? And that's our value for I1. Okay. So if we kind of look back at the circuit here, so we know that this current is the same in this wire up until this point where it has to break off. We know that some will go this way and some will go that way. And if we have those two in parallel, from our concepts, we can use current division because they are in parallel. So if we do that, I'm going to draw just this. This is 8, and this is 8. And then this is I1, and this will be I2. Okay. So if we want to find what I1 is, I2, we can say that that our R parallel over let's see here. So we actually have a couple options of what we want to do. We can either do voltage division or current division. But for this one, let's just stick with the current division since we already have that one set up. Okay. So here, hold on, did I get a... So like we said, the R equivalent here, R parallel is going to equal our R equivalent. Just trying to keep the equations consistent. We'll travel over this R8. I'm just going to call it R8 because it's got 8 ohms. Multiplied by I1. So our original equation is I of whatever number over R equivalent times R, whatever that number is, times the source current. But the source current doesn't necessarily have to come from like a battery source or a voltage current source. It's just whatever's being split up. So in this case here, I1's being split up, so that's our source current. So if we go and plug and chug, we already found the R parallel value. And we know it's 8 here, 8 ohms and ohms. We're going to multiply it by the source current, 1 amp. And this will give us 0.5 amps. And that'll be equal to I2. Okay. Does everyone see how we got here? Does anyone have any questions about this problem? All right. Okay. Hearing none, so I will move on to the next problem. And just an interesting little topic before we do, I guess. Looking at that KCL, we've got 1 amp coming in, right? Then we said we had that 0.5 going in, going down to the right. So what will this one be? If we do some entering, some leaving, 1 amp is equal to 0.5 plus the question mark. So therefore, question mark is equal to 0.5 amps. And notice that's the same value for both of those. And the reason why is the current wants to travel down the path of least resistance. But if you look, both of these are 8. And because both of them are 8, it is indifferent to where it sends its current. So it'll split it up evenly.